Bismillahirrahmanirrahim. So let's do our first plotting. My previous videos were based on special cases of transmission line. So open circuit, short circuit, and mass scenario. So we're going to look at this example first on a Smith chart. Okay. I know something about the impedances of my open circuit. I know open circuit is infinity. All right. Short circuit is 0. And Z matched is actually a scenario where ZL is equals to my Z naught. So let's look at all of these scenarios and let's try to calculate, let's try to find out what would be the reflection coefficient and what will be the value of reflection coefficient and what will be the value of their angle as well. Okay, so in order for me to do that, now let's just focus on this. So this is my real axis right here. All right, so this is my real axis. When my real axis, so my real axis, I'm just going to write here. So this is my real axis. And these lines are my inductive lines. And these lines are my capacitive lines. All right. So these are my real. So this is my real axis. These circles that you see that are going like this, these are my real circles, as you can see, and these are my inductive lines and these are my capacitive lines. Capacitive lines are at the bottom, inductive lines at the top, and these circles that you see, these are my real circles. Okay, now let's look at it. Let's plot this impedance infinity for an open circuit. So when I want to plot this, if I were to go from here, the value on this Smith chart are normalized values. Normalized values means that whatever your characteristics impedance is, whatever your load impedance is, you're going to divide that by your characteristics impedance. Whatever the values are going to be there, they are all going to be present on this line in real axis at the same time on your inductive and capacitive region. So if I were to look at this open circuit Z naught, for open circuit Z open circuit is actually infinity. So if I were to look at this value and if I move across, these values tends to get bigger, isn't it? And they are going all the way up to infinity. So basically, if you were to continue this, getting bigger means it is going towards infinity. All right. So far, so good. So this is going all the way up to infinity. So this is where I'm going to plot this point to be right here at this. So this is, imagine this is going towards infinity. Now, if I were to look at angle of reflection for this, what is the angle of reflection of this? The angle of reflection for this guy, if I'm starting off from here and it's going all the way up to 180 and then all the way up to 360, so it's just 0 degrees, isn't it? So reflection coefficient, we're going to find that out, but the angle that we're getting is about 0 degrees or 360 degrees, which means if I have an open circuit, if I have a wave that is moving towards my load, it's going to return back. If I have an open circuit, it will return back with the same angle that it went through. So if it started off, let's say with 0 degrees, it's going to return back at the same angle, which means jacking up the voltage value. That's what it means. So angle right here, because if you were to look at it, angle of reflection right here is going from 0, 20, 30, 40, all the way. This is the one that I'm looking at. This is the one that I'm looking at. So it's going all the way up to 0, all the way up to 180, and then all the way up to 0, going back to 360 degrees or 0 degrees. So it is an angle of 0 degrees. Let's try to find out what is the reflection coefficient for an open circuit is going to be. So the best way to do it is this. You take a piece of paper. Let's take a small piece of paper like this. And you measure the line. You measure the line from your center. So let's say I'm starting off from my center. You take a piece of paper. You always start off from center, where 1 is, and go all the way up till here and mark this point. So let me take a piece of paper. So we're starting off from this, going all the way up to this end point right here and mark this position right here. Once you have marked this position, starting off from here all the way up to here, now the next thing you need to do is go right here at the bottom of your Smith chart, and you look for reflection coefficient with respect to E or I right here. This is the value that you're looking at. Reflection coefficient E or I. Now, you take that piece of paper where you have marked those points. You always put them at where the origin is. So I'm going to start off with this point which I marked, and I'm going to put this right here at the center, and I'm going to measure this. So if I were to bring out this value, so I'm starting off from 0, 0, 0 0.1, 0 0.2, 3, 4, 5, 6, 7, 8, 9, 10. It's about 1. So the reflection coefficient, as we did it theoretically, is actually 1. So the reflection coefficient for a open circuit, now the reflection coefficient for an open circuit is actually, the magnitude is 1, and it's reflecting back with the same angle. Now when I want to plot short circuit, what is the impedance of a short circuit? So this is my real line. It's actually my short circuit is actually 0. Where does it 0 on this line? If this is infinity, then definitely 0 is starting from here. Okay, so where is my short circuit? If this is my real line, if this is infinity, then definitely this is 0. So this is the point. This is what my 0 is. Okay, now let's look at it. What is the angle of reflection? So angle of reflection is this guy, not this circle. It's actually this circle. This circle is going all the way up to 180 degrees. So it reads 180 degrees. So the reflection coefficient for a short circuit, and if I were to take the same value, is going to be an angle which is going to be 180 degrees. And now I'm going to mark the same point. This is the same value as it goes from center to here is going to be exactly the same value. Let's put our page here, right here, and mark these 2 points. This is exactly the same length. Now you would go back at the end of the paper, and then you're going to mark this point. And indeed it is 1. So reflection coefficient for a short circuit is going to be 1, but with an angle of reflection of 180 degrees. Now, reflection coefficient, the magnitude is going to be 1, but it's going to be 180 degree out of phase. So if my signal is traveling like this in a short circuit, and if it encounters a short circuit, the reflection is going to be an opposite of this. So it's going to be, so it's actually going to kill the signal like this. Like this. It's going to be 180 degree out of phase. So if my signal is going like this, it's going to return in an opposite direction like this, which means it will actually eat up your entire signal. This is in terms of a short circuit. Now when it comes to a match circuit is this. Match circuit is, what is the impedance of a match circuit? Is going to be 1, and 1 is just right here at this point. This is my center. This is right here. This is my center point. This is the 1 value. So this is going to be my 1 value. And if I were to take this and if I were to plot it like this, what is the reflection coefficient at this point? The reflection coefficient right here for a match scenario is going to be 0 right here, because this point is just going to be right here. So reflection in match scenario, impedance is 1, which means it's right dead at the center. And if I were to draw this line, this is just going to be 0. There is no angle associated with it. There is no angle that is there. So this is how you actually plot the values of a short circuit, open circuit, and your match circuit on a Smith chart. If you have any questions, please leave it in the comment section, and don't forget to like and subscribe to my channel.